Hello everyone. Today we are going to solve one problem using Meyerhof bearing capacity equation. So let's see the problem. A rectangular footing, the size is given 2 meter by 3.5 meter, is placed at a depth of 1.5 meter. So you have a footing. And this footing has been placed below the ground surface or ground level at a depth of df equal to 1.5 meter. The width of the footing is given to you as 2. And the length of the footing is 3.5. And the ground properties are given to you. C is 20 kilopascal, phi 22 degree, and the unit weight is given as 18 kilonewton per cubic meter. And the groundwater table is very deep. That means there is no effect of groundwater table on the bearing capacity. So you will have to determine the ultimate bearing capacity and net ultimate bearing capacity and net allowable bearing capacity of this foundation for factor of safety equal to 3 using Meyerhof bearing capacity equation. The bearing capacity factors are given to you for phi equal to 22 degree. Meyerhof table has given bearing capacity factors NC equal to 17.16, NQ 8.12, and N gamma is 4.46. Inclination factors are 1. That means the load is acting vertically in the downward direction. So that has been taken as 1. So let's solve this problem. According to Meyerhof bearing capacity equation, the ultimate bearing capacity can be found out. So the equation is known to you. In the last video, you have seen that the ultimate bearing capacity is given as CNC into shape factor, depth factor, inclination factor, plus Q bar, that is the surcharge, into Q and Q into SQ, DQ, IQ, plus 0.5 gamma B, N gamma, S gamma, D gamma, I gamma. So this equation is for ultimate bearing capacity of this side. So let's calculate. NC is known, but what is the shape factor? The shape is rectangular, and therefore the shape factor formula I have given you in the last video, that is 1 plus 0.2, and the shape factor is taken as P by L into tan square 45 plus 5 by 2. So you can calculate this value. And SQS gamma, another shape factor, is to be calculated. The formula is 1 plus 0.1 B by L into tan square 45 plus 5 by 2. You have to calculate this. And then calculate the depth factor. DC equal to 1 plus 0.2, and the depth of the footing D divided by the width of the footing into tan 45 plus 5 by 2. So we have to calculate this, and dq d gamma is going to be 1 plus 0.1 d by b into tan 45 plus 5. So phi is 22 degrees, so you will have to add 11. So this becomes tan 56. And inclination factors are already given, that it is 1. So no need to calculate that. Inclination factors are to be calculated only when the load is going to be inclined with the vertical. So let's take our calculator and calculate the values. So one plus 0.2 into the value of B is 2 meter, 2 divided by L is 3.5 meter, into tan square 56 degree. So into tan 56 square. So this value comes out to be 1.25. To 2 decimal places we will take it. So 1.25. Similarly, calculate now SQ, S gamma. So here the only difference is there is 0.1. This is giving you 1.125, we will take it 1.12 up to 2 decimal places. Then the depth factor DC is 1 plus 0.2. So let's calculate it. .2 into D divided by D is given to you as 1.5 meter. So make it 1.5 divided by B, that is 2 meter. 2 into tan 56 degree. So if you calculate it, 1 plus 0.2 into 1.5 divided by 2 D by B factor into tan 56 comes out to be 1.22. And here it is going to be 0.1 dq d gamma. So let's calculate this also. So if we calculate this gives you 1.11. Having calculated shape factor, depth factor, inclination factor, now the next task is to calculate the ultimate bearing capacity. Therefore, the ultimate bearing capacity equal to C is given ground properties as 20 kilopascal and NC is 17.16. SC you have already calculated as 1.25. DC is 1.22 and inclination factor is 1 plus. There is the surcharge Q bar at the base of the footing, and that's gamma. Gamma is given the problem as 18. So the surcharge will be 18 gamma D. So D is 1.5. That becomes Q bar multiplied by NQ. NQ we have calculated. It has been given as 8.12. So 8.12. The shape factor SQ we have calculated as 1.12. DQ has been calculated as 1.11 and IQ is 1 plus. The third term is 0.5 into gamma, that is 18. B is 2 meter. N gamma is given as 4.46. N gamma. S gamma we have already calculated as 1.12. D gamma is 1.11 and inclination I gamma is 1. So if we calculate it, we will be getting the values. So let us calculate. This gives you 523 first term, 0.38. This has been calculated. Plus the next term, let us calculate. 18 So this term is gamma D NQ SQ D, and this comes out to be 1.1. This is equal to 272. So this term is 272.55 plus the third term. So let us calculate the third term. This is 99.80. So if you sum up the answer comes out to be 895.73 kilopascal. So this is the ultimate bedding capacity. Therefore, QU, that is the A part, is known to us. QU equal to 895.73 kilopascal. That's the ultimate bearing capacity. Now, the net ultimate bearing capacity, if you want to calculate, the A part is over, B part. The net ultimate bearing capacity, the formula you know that it is going to be first term, no change, CNC, SC, DC, IC plus second term is going to be Q bar NQ minus 1 into other terms remain same, SQ, DQ, IQ plus 0.5 gamma B, N gamma, S gamma, D gamma and I gamma. Right? This is net ultimate bearing capacity. So first term, there is no change. So it is going to be 523.38. Here it is NQ minus 1. So this needs to be calculated. So let's calculate it. So if you calculate it, (18 into 1.5) and NQ minus 1, it becomes 7.12. So into 7.12 into 1.12 into 1.11. This gives you 238.99. 238.99 plus there is no change in the third term, that means it is 99.8. So finally, if you calculate, let us see 523.38 plus 238.99 plus 99.8. 862.17 kPa, kilopascal. This is the value of QAU. So you have been able to calculate QNU as 862.17. Next, last part of this problem is also calculate the net allowable bearing pressure for factor of safety 3. So net allowable E will be net ultimate divided by a factor of safety. So if you calculate, this becomes 862.17 divided by 3. This comes out to be 287.39 kilopascal will be allowable bearing, net allowable bearing pressure. So by using Meyerhof bearing capacity equation, we have been able to calculate net ultimate bearing pressure, ultimate bearing capacity, net ultimate bearing capacity, net allowable bearing pressure for factor of safety equal to 3. So all the 3 parameters have been calculated. So with this, we have completed this problem. Now, if in this problem there is any effect of water table, say you have a water table effect, the water table is touching the base of the footing, what will you do? Then it is going to affect your third term, and there this gamma you should replace by gamma prime because of the submergence in the third term. If the water table goes up, then you know that in the second term this Q bar will get changed. So if the water table is coming up to the ground level, then your Q bar is going to be gamma prime because of submergence into the depth of foundation. So here we have taken, because the water table was very, very deep, we have taken this value as gamma into D. But due to submergence, you will have to use gamma prime if that case arises. So this is how we should solve it. Thank you very much.